Section 4 of Louis Pasteur by Albert Keim and Louis Lumet, translated by Frederick Taber Cooper. This LibriVox recording is in the public domain. Recording by Pamela Nagami. Chapter 3, On the Road to Fame, Part 1. It needs only a brief examination in order to realize that the works of Pasteur, even those most widely different in appearance, follow one another like the links of a chain, and present an admirable unity. Toward the end of his studies of crystals, his ideas became generalized and extended his theory of molecular dissymmetry to the constitution of the universe, while a certain laboratory experiment was destined to turn his attention to ferments. Having broken a crystal of tartrate, Pasteur plunged it again into the mother liquid, and discovering that the crystal became restored in its entirety, he compared this breakage to a wound which is healed with the help of new molecules of its own kind. On the other hand, he had observed that the tartrates undergo veritable fermentations, and he believed that these fermentations might be due to a microscopic organism which played the role of a ferment, so that, setting forth from crystallography, he finally arrived at researches into the origin of life. Having been appointed professor of chemistry and dean of the faculty recently founded at Lille in 1854, Pasteur, while faithfully fulfilling his pedagogical duties, prepared to carry on his studies of fermentations. He spared no pains to prove himself worthy of the confidence placed in him by M. Fortoul, the Minister of Public Instruction, and he succeeded in raising the new faculty entrusted to him to the first rank of scientific establishments. More than 200 auditors attended his courses, and 21 students were enrolled for practical work in the laboratory. He exerted himself to carry out the program of the minister, whose desire was to train operators and practical workers in the higher manufacturing industries, but he never ceased to repeat that nothing counted apart from theory, and that theory alone could be productive of great results. At the same time, Pasteur initiated his students into industrial methods by taking them to visit the manufacturers of the neighborhood, where they were able to judge at first hand which were the best of the methods employed. Furthermore, the General Council of the North recognized the practical value of his knowledge and his teaching by entrusting him with the examination of the fertilizers essential to agriculture. The problem of fermentations, which Pasteur was preparing to solve victoriously, was even more obscure than those offered by crystallography. How did the heavy dough, formed of flour mixed with water, become the light and substantial bread? How was the crushed grape transformed into wine? Undoubtedly, these questions had occupied the attention of man ever since the most remote antiquity, and many answers were made to them, but no answer that was scientifically satisfactory. The alchemists of the Middle Ages thought that yeast had a certain power of transmutation, and that fermentation, if applied to metals, would enable them to transmute a base metal such as iron into a precious metal such as gold. The first of all to approach the truth was Paracelsus, who compared fermentations to diseases. But his idea was still vague and not based upon experiments. We must wait until we come down to Lavoisier in order to see fermentations studied upon a basis of facts. But neither this great chemist nor those who followed him, Gay-Lussac, Cagniard-Latour, Schwann, Helmholtz, Liebig, succeeded in demonstrating their real origin. The theory most generally accepted at the time when Pasteur began his researches was that of Liebig, who attributed fermentations to matter in the course of decomposition, which played the role of a ferment in the mediums into which they were introduced. It was in a sugar refinery at Lille, owned by M. Bigot, that Pasteur entered upon the study of fermentations. He approached it equipped with all the knowledge acquired through his work in the tartrates, which must have singularly aided him to reach a solution of the problem that had been so long and vainly sought. We cannot follow him through these delicate and difficult experiments, but he arrived at this luminous and unforeseen conclusion that fermentation was not a phenomenon of death, as Liebig had thought it, but a phenomenon of life, and this he proved in an irrefutable manner. His experiments, which were directed more especially to lactic and alcoholic fermentation, showed him that all fermentation was due to the presence of living cells, which alone were the active agents of the transformation. These cells had a life of their own, and the phenomena of fermentations were closely connected with it and influenced by the different phases of its evolution, according as these cells were ill, dying, or in full vigor. This was indeed a light thrown upon what had hitherto been nothing but darkness, a discovery which was destined to create an entire new science, and of which the consequences were at that time incalculable. The scientific associations, both in France and abroad, disturbed at first by Pasteur's far-sighted genius and by the unforeseen results of his researches, awaited his communications with something bordering upon impatience. He received recognition beyond any of the other young investigators, for he had proved himself to be one of those with whom it was henceforth necessary to reckon. He began to receive recompenses. In 1857 the Royal Society of London bestowed upon him the great Rumford Medal for his work in crystallography, and the same year his friends in the Institute, and Biot among the first, who felt a paternal affection for him, urged him to present himself as a candidate for the Academy of Sciences in the section of mineralogy. Pasteur accepted this flattering invitation from the masters of his profession, who now looked upon him as at least their equal, but he made a rather sorry candidate, being too fond of truth and justice to be willing to play upon those little human vanities which assure success in all elections. Accordingly, in spite of Senarmont's report, which was highly eulogistic of Pasteur's discoveries, insisting upon their value and importance, Pasteur received only 16 votes. He took his way back to Lille, not greatly cast down by a defeat which he had foreseen, but he remained there only a short time, because on the opening of the scholastic year of 1857 he was appointed administrator of the École Normale and director of the scientific studies, while Nissard assumed the general direction. Henceforth this was to be the centre of Pasteur's life, his whole life of toil, of combats on behalf of science and humanity, and his family life as well, a very happy one, notwithstanding that it was destined to be marked by some inevitable bereavements which his profound faith as a Catholic aided him to bear. It was from the little laboratory in the Rue d'Ulm that the great and peaceful revolution was to proceed, designed to cure all the ills of life by penetrating the secrets of nature. It ought to be regarded as a sacred spot, for one of the finest of all human minds lived and thought there, while such high virtues as courage, perseverance, and moral strength were there put into magnificent practice. M. Maurice de Fleury has related how Pasteur never ceased working, even when his laborious day was ended. During 15 years, he says, he could be seen each evening after dinner pacing up and down a long corridor where no one dared to come and interrupt his reverie. Paralyzed since 1870, for on 2 different occasions apoplexy attacked his brain, he would seize the bunch of keys in his pocket with his stiffened hand and make them rattle in order to soothe his thoughts with the rhythmic sound, and as he walked he slightly dragged one foot, while his mind ripened some newly conceived idea or prepared for the experiment of the morrow. At times his reverie assumed the intensity of ecstasy, and within the brain of this man of genius flashes of light revealed his goal and gave him a prevision of all that was destined to emanate from him. "How beautiful it is! How beautiful it is!" he would murmur in low tones. Then, resuming his pacing with a firmer step, he would add, "I must work." And so he would continue until the hour of 11. Is there not something deeply touching in this picture of the great man toiling on into the night, after all the experiments he had made during the day, experiments made under very hard conditions? His laboratory in the École Normale was, as a matter of fact, exceedingly primitive and inconvenient. It consisted of 2 inadequate rooms which he himself had contrived in the garret, and while it was freezing cold in winter, during the summer the temperature would rise to 97 degrees Fahrenheit. Nevertheless, it was here that he completed his studies of fermentation from 1857 to 1859, and notably those of alcoholic fermentation. It was here also that he was destined to discover a phenomenon which overthrew all accepted ideas regarding the essential conditions of animal life. No one had questioned that oxygen was a necessity to all animals without exception. Pasteur proceeded to prove that for certain species it was fatal, and that they died at its contact. While examining under the microscope a tiny drop of butyric fermentation placed between 2 very thin sheets of glass, Pasteur observed that the bacteria known as the Vibrion, which produce this fermentation, were very lively at the centre and furthest from the air, but that those near the border line became inert. What was he to conclude from this phenomenon, which contradicted all observations that he had previously made of various infusions in which the animalcula left the centre of the drop in order to draw near to the margin which supplied them with more oxygen? Was it possible that there were animal forms which made an exception to a law that was supposed to be general? Were there some that led an anaerobic life, that is, without oxygen, while it had previously been regarded as settled that all animals led an aerobic life in which oxygen was necessary? Pasteur solved this question by passing a current of air into a flask containing a butyric fermentation, and immediately the life of the Vibrions diminished in intensity and finally ceased. The proof had been obtained that there were animal forms to which oxygen was fatal. But how did it happen that these anaerobic Vibrions had not met with oxygen in the medium in which they were bred? It was because the aerobic Vibrions, which preceded their evolution, had exhausted all the oxygen in the liquid, and thus gave them a chance to live and multiply. Furthermore, these 2 forms of life were found coexisting in the same liquid, a part of the aerobic forms having died and fallen to the bottom of the vessel after exhausting the oxygen, while the more vigorous rose to the surface and continued to live, thanks to the oxygen in the air, and formed at the same time a protective layer for the anaerobics, which were thus enabled to develop in the lower depths. Pasteur was destined later on to study in detail these phenomena which no one before him had observed, and to gather new light from them. M. Duclos emphasizes the element of genius in these researches. "I have tried to present all these deductions as a whole," he writes, "because, as a matter of fact, they were the result of a few weeks of work and meditation, and also because they afford us an example of Pasteur's power of penetration in perceiving and outlining a problem, and the patience he exhibited in gathering together the elements essential to a solution. Throughout the best years of his life this man lived in advance of his time, a pioneer lost in solitude, absorbed in the contemplation of the horizons he had discovered, and which his eye alone could behold and traverse. What is less surprising than his indifference to the details of actual life? He lived in his own thoughts without being a dreamer, for a dream which reaches its goal and produces results ceases to be a dream. End of section 4.